So in this part, this is actually the last part of the climate change lecture series. Um, so this one will focus largely on how climate change could impact human health and hygiene. So this map you are looking at is based on a mathematical model that indicates the likelihood of summer droughts happening in global scale and how that likelihood change compared to a particular reference point. The global reference point comes from the summer precipitation um, from 1961 to 2007. And what the model is trying to do is try to look at the summer drought incidence. Now, how did they measure drought based on precipitation data? For each particular surface area, they were trying to calculate the incidences where the projected or the future precipitation can decline all the way up to 10% of the historical precipitation coming from the reference points. Now, what is summer according to them in this definition? Well, they define summer as the time frame from June to September. And now let's look at what does this map indicate. So the areas that are coming up in green, which is actually kind of captioned the same, indicates the areas that are unlikely um, to have major changes in their summer droughts or reduction in summer precipitation. And the areas that are coming in different shades of reds or browns indicate different severities of the summer drought. Um, so, for an example, what do you mean by double? Right, well, the areas that are actually colored, in that the shade of brown, the term double means doubled frequency of summer droughts. Now, what does that mean? Let's assume that there's a particular area that historically gotten droughts once in every 10 years. Doubling means now they will get a drought once in every 5 years. What does triple mean? Well, if there's a particular area that is known to get droughts during summer once in every 15 years, now they will get a drought once in every 5 years. And so far and so on, right? Quadrupling meaning actually increasing the frequency of the drought by fourfolds, right? If you get a drought in once in 20 years, now you get it in once in 5 years. Okay, so and you do notice that the increased frequency of summer droughts are likely to happen all over North America, right? Largely within the northern Midwest, right? And extremely likely to have increased drought incidences in southern Florida, right? And also a large part of the northwestern United States is likely to suffer from summer droughts, right? And also look at Mexico, right? Um, a huge proportion of Mexico, parts of southern Mexico and certain parts of Baja California are likely to have a great incidences of droughts. And all the Caribbean islands are likely to suffer from droughts. Now, if you look at the European side, um, the southern Europe, right, particularly Spain, is going to have larger incidences of uh, summer droughts. The same situation regarding northern Africa. So generally, that's why we are looking at zoomed into this particular part of the map, because this particular model recognizes that the future likelihood of increasing summer droughts will happen mostly in North America, parts of Mexico, southern Europe, and northern Africa. So so what? What's the problem? How can we relate this increasing summer drought incidences or decreasing precipitation to human health? Well, droughts and heat waves, right, collectively can induce heat strokes, heat strokes, that can impact human health, human activities, their daily routine work, right, and also can result in thermal stress. And thermal stress, like depending if it is acute, short term, maybe the impacts are not that bad. But if um, this in the if the thermal stresses or heat strokes are going to be chronic, if this is going to happen over a long period of time in shorter intervals, well, then that actually could even have certain neurological impacts. These kind of climate induced stresses can actually also damage your immune system. And um, so this increasing summer temperatures, as predicted, and resultant prolonged droughts, could inevitably have health impacts. And you also know that increasing droughts and prolonged droughts can also increase the incidence of transmittable diseases. And there are some evidence suggesting that it could actually also increase vector-borne infections like tick diseases or mosquito-borne infections. So these summer droughts or decreased summer precipitation can actually result in many human health complications. And continuing on, climate change, uh, how climate change impact human health. We know that climate change can result in famines and famine-related consequences that can impact the human society significantly. This example comes from the continent of Africa. So climate change related impacts like droughts can result in a famine. Droughts result in resource scarcity, particularly water, and also scarcity of suitable herding grounds for stocking farmed animals, um, reduction of lands for grazing, reduction of suitable lands for sowing crops, right? Or crop failures can result in as a result of a drought. And so this map you are looking at, is again centered on the African continent. The map shows four different climate change related impacts: drought impacts, famines, floods, and epidemics. Pandemics that are starting from climate change related phenomena. So the circles you see corresponds to the number of people impacted by those four types of natural disasters, right? And the numbers are drawn, or the circles are drawn in correspondence to not just the number of people, it's actually the millions of people impacted is what's shown in this particular map, right? So the larger the circle, the greater the impact. um, so we do see that the droughts have severely impacted parts of eastern Africa, so, and then also parts of the Sahel area that's kind of found immediately south of the Saharan belt, right? And then you do see famine impacts, largely restricted to the African Horn or the Eastern African part, where where you get like repeated occurrences of famines, and then certain parts of Western Africa, it's also equally worse. And flood related problems, again eastern part of Africa as well as certain parts of the Western Africa, right? And disaster related epidemics. I feel like that particular map is heavily underrepresented. You only see fewer circles. One reason is that these kind of problems have happened in Africa for quite a long time. So the African people may have evolved some sort of a herd immunity against um, epidemics and pandemics, right? But I also feel like there is some sort of a data scarcity that kind of underrepresents the severity of epidemics over there. But in either case, you do see kind of a continental wide impact even with related to diseases, although the number of people affected could be less compared to droughts, famines, and floods. Um, how does climate change impacts human health through increasing incidences and prevalence and expansion of infectious diseases and vector-borne diseases? So, infective agents, including parasites, disease vectors, they are known to increase in abundance with climate change, particularly with warmer temperatures in most cases, and in fewer cases with increasing wetness. Um, and there are evidence suggesting that with global warming or increasing sea surface temperatures, the rate of reproduction, dispersal, and survival of these parasites and disease vectors are going to increase, right? In other words, mosquitoes, particularly, are known to expand their range with warmer temperatures. Uh, and certain parasites could actually increase their survival inside the host, and certain viruses can survive outside the host for longer time with increasing temperatures. And like I mentioned earlier, the malaria transmission have increased, or expansion of the malaria range has increased in African continents as well as in the Indian subcontinent. That correlates with increasing temperature trends. And also other waterborne diseases like cholera have increased um, in both in numbers as well as in spatial distribution in Bangladesh, um, because with warmer temperatures, the water temperature increases, which actually increases the favorability of reproduction and spread of zooplankton. And cholera turns out to kind of hitchhike this zooplankton and survive inside the zooplankton, particularly in the warmer temperatures. So that's actually one of the reasons why this happens. And tick-borne infections, in particularly tick-borne encephalitis, which actually impacts your nervous system, your central nervous system. That disease has expanded its range in Sweden with increasing temperatures, and particularly in northern Scandinavian countries like Sweden, temperature keeps these infectious diseases at bay. But with warmer temperatures, you might actually experience um, diseases becoming more prevalent in northern latitudes and in southernmost latitudes and in northernmost latitudes. Um, certain diseases can actually kind of creep up, um, tracking warmer temperatures. In Southeastern Asia and in South America and in Central America, dengue hemorrhagic fever um, have increased in incidences that parallels warming temperatures. Now, dengue hemorrhagic fever is transmitted by a mosquito, um, and which actually results in internal hemorrhage, which could result in death, especially if you contract it more than once. The chance of your survival goes dramatically down. And the rate of the probability of a particular patient contracting dengue hemorrhagic fever twice can also increase with projected trends in climate change. Let's look at the three graphs now we are looking at from the top to bottom. And the top one, well, in fact, in all graphs, the y-axis, x-axis is the year, um, y-axis on your left-hand side is going to be the number of cases reported in thousands. The y-axis on the right-hand side, you're looking at some form of mosquito index predicted based on climate change scenario. So look at the top graph now, right? You're looking at Honduras. It's a Latin American country, right? The dashed graph, the dashed line in the graph is the model for the mosquito index developed based on climate change. The solid line is actually the actual number of cases reported um, for reported by Pan American Health Organization. PAHO stands for Pan American Health Organization, right? So, and in all cases, you are looking at the number of cases we are looking at is the number of patients recorded to have contract dengue hemorrhagic fever. Um, and the mosquito index refers to the specific species of mosquitoes that spreads dengue. Um, Now we can see clearly that the actual number of cases reported versus the climate change generated mosquito index perfectly overlaps with each other. That provides enough evidence to support that with increasing warmer temperatures, you have more abundance of mosquitoes, right? Which parallels increase trends of disease transmission. The same trend has been found in Nicaragua, right, as well as the third case, the lower graph is we are looking at Thailand. It's a Southeast Asian country, right? Um, Again, the projected mosquito indexes based on climate change perfectly matches the trends observed in actual cases reported. Now, we earlier were talking about how climate change impacts human health, and the previous example was with related to mosquito-borne or vector-borne diseases. So now we are continuing on the same track, and there's increasing evidence that the industrial smog formation happening more frequently, and that smog lasting longer with increasing atmospheric temperature. Now, what is industrial smog? You all know that. We have been talking about the industrial smog in China that lasts for weeks, days, and the same thing happening in Japan. So, what is industrial smog is when industrial activities emit their gaseous effluvia, which primarily comes from burning fossil fuels and producing many other products. If the chimney that actually outlets or that emits the exhaust isn't tall enough, it lingers in the lower atmosphere. Different industries release different types of gases, as a byproduct, as a waste product, for the matter of fact. And sometimes, those different exhausts combine with each other, with water vapor, with dust, and under warming trends, such mixture of industrial gases remain in the low atmosphere and contaminate the air we breathe. Um, Now, if you look into the constituent gases of an industrial smog, it could contain ozone, and ozone naturally exists in upper layer of the atmosphere, but ozone is not natural, it's unnatural to be found in the lower atmosphere that we breathe. But industrial activities, the smog, may contain ozone. Now, that ozone is quite harmful to the human respiratory tract. It could irritate the respiratory tract, so you would have inflammation in your lungs or in anywhere in the respiratory system. Subsequently, if you're exposed to ozone for a prolonged time, or to industrial smog for a longer time, you might suffer from reduced lung function. And it's also going to aggravate asthma. It doesn't cause asthma, but if you suffer from asthma, which is, could have a genetic predisposition, if you suffer from asthma, the um, the predicament that you face could be severe under the presence of industrial smog. Um, and also, industrial smog, the content gases of industrial smog could damage the epithelial layers of respiratory system, and also in the epithelial layer or immediately below the epithelial layer of the respiratory tract, there's immune system. Okay, particularly there's a particular immunoglobulin or an antibody called IgA that's job is to protect the lungs or the respiratory system. But under industrial smog, the immune functions can also be impaired, and the respiratory tract lining can be impaired. Hence, it exposes you to other secondary infections. And I did already mention the fact that some of the gases could actually irritate your lung, and ultimately that leads to inflammation of the lung epithelium, which could lead to severe situations. For instance, you could bleed, in your lungs. So this slide contains an embedded video that you can play yourself, and I'm not going to add anything here. Just listen to the video, and that's it for this slide. So, how do we combat climate change? What kind of actions can we take to prevent climate change, which you already know by now through many other lectures and through many other conversations we have had. But I want to talk about um, some actions that we can take in terms of adapting ourselves to climate change. So this goes simply beyond um, cutting down carbon emissions. This goes simply beyond innovative energy technology or engineering. First one, connectivity conservation. Now remember what I mentioned about what happens to species, or how certain species will respond to climate change. I mentioned that certain species will actively move from their current habitats in search of other habitat which provides the physiologically optimum conditions. um, when they migrate, they cannot migrate through unsuitable habitat from one suitable habitat to a futuristic suitable habitat. In order to migrate from between these two, they need to have some sort of a connection, some sort of a corridor that supports their survival during the migration process. So, creating and establishing connectivity between different conservation land, different habitats is important to support movement of species from low elevations to higher elevations, from lower latitude to higher latitudes. Now, this kind of conservation requires acquisition of certain conservation lands, managing other lands in a way to assist wildlife migration, bird migration, butterfly migration, and also um, alongside with connectivity conservation, we might have to identify certain species that are more vulnerable to climate change that requires monitoring, right? And monitoring animal populations, wildlife populations, and identify species that are more vulnerable to climate change. And maybe certain species may not survive it. Not every species is going to migrate to suitable habitats in face of climate change. So those species that are unable to migrate may require other conservation actions, such as through ex situ conservation. Sometimes zoos, botanical gardens may be the only location where some species may continue to live given the current trends of climate change. The next one is actually environmental policy. We talk again about this a lot. So, Clean Air Act is a national policy that ensures that the air we breathe is cleaner and breathable. So, and the same act can be kind of shoehorned into reducing carbon emissions, reducing greenhouse gas emissions to the atmosphere, and also creating certain carbon sink type environments, habitats that actually extract existing carbon in the atmosphere and kind of sequester it away from the atmosphere so it doesn't contribute to enhanced greenhouse effect. Now, on that line, the National Wildlife Refuge System of the United States, which is uh, mandated and governed by U.S. Fish and Wildlife Service, um, have started, through that program, the U.S. Fish and Wildlife Service have started to work collaboratively with private and state agencies um, to protect conservation lands that are non-publicly owned, that are privately owned, and grow or restore hardwood forests, because hardwood forests are one of the best carbon sinks in North America, works better than any other type of habitat we can think about. So that is ongoing effort in southeastern US. This has been particularly targeted in the southeastern US because in southeastern US we have the fastest growth of vegetation, the best climatic condition for tree growth. So works really well to sequester atmospheric carbon and store them as biomass. Clean Air Act is actually regulated by the Environmental Protection Agency. Um, so finally, what I want to mention is that taking actions against climate change and climate change associated air pollution preventing air pollution should entail a multidisciplinary action plan. It requires, new land use planning, which encourages growth of trees, hardwood trees, forest conservation, um, and also providing economical incentives for novel, environmentally friendly land use planning, and also doing biodiversity conservation, wildlife conservation through corridor connectivity, like I just mentioned, through ex-situ conservation through monitoring strategies and all that, and also educating the public so that the public, when it comes to elections or selecting their own representatives for the government, the public can be more cognizant of um, what kind of politicians are more conducive to environmentally friendly policies. And of course, the energy sector has to go through a huge renovation. It is currently going on in different parts of the United States. So again, climate change mitigation requires interdisciplinary participation, interdisciplinary involvement. So what kind of disciplines? Policies, energy sector, education sector, conservation sector, and land use planning sector, economy, so on and so forth. So um, now it's good time to talk about some of the international agreements that has been set forth historically to combat climate change. We all have talked about the Paris Accord and the impacts of the US walking out of the Paris Climate Deal. Now, this Paris Climate Deal has a history. This started first in 1997 in Japan, in the city of Kyoto, and hence this accord is named Kyoto Protocol, which involved originally about 192 signatories that agreed to, in different ways, to reduce the overall carbon dioxide emission. The overarching goal of this Kyoto Protocol was to create kind of a convention, an international convention, and an agreement to roll back on carbon dioxide emission by different countries. Well, not just carbon dioxide emission, to roll back on emission of carbon dioxide, methane, nitrous oxides, and other greenhouse gases, and to cut those back about 5 to 10% below the levels that was recorded in 1990 by 2012. Again, the idea was for the participating nations to cut down their greenhouse gas emissions by a range of 5 to 10% below the levels existed in 1990. And that level uh, was planned to be reached by 2012. Now, was this a successful? Well, no, it was not. Many countries did not reach um, their original plan. Okay, and of course, throughout the course, different countries walked out of the plan, and US didn't sign it at that time either. And as you can see in the map, only Russia met the targeted reduction, and that is by simply inaction. In this time frame, Russia was undergoing huge economic collapse, and the result of that economic collapse is the collapse of industries that emitted vast majority of greenhouse gases to the atmosphere. And during the process, there were many issues that certain signatories didn't like. For example, China and India, two fastest developing countries, were exempt from the need to roll back. So they could keep emitting carbon dioxide as much as possible. So they are developing countries. That was the reason it was given, that chance was given to them. But as you can see, it is not a fair game, or was not seen as a fair game by many other developing countries, including Japan, Canada, right? And so they walked out of the deal because they see it being unrealistic, and they wanted to adopt their own national climate action plans. For example, Canada figured out that they had better work on their own and develop their own climate action plan, and they did, and they succeeded. So Canada kind of saw being in the Kyoto Protocol as kind of a disadvantage because they couldn't reach their They wanted to, because the agreement was unmonitored, and there was a lot of uncertainties when the Kyoto Protocol was signed. So it was not a great success story. What are different options for controlling emissions or regulating emissions? Well, carbon trading is one of the approaches which was supported or favored through Kyoto Protocol, but carbon trading can happen outside the Kyoto Protocol, and it is happening internationally as well as between companies, between different organizations within a country. Um, Now, let me explain how carbon trading works. Now, carbon trading creates kind of a global market, kind of creates a new industry. Um, and there is a trend in different parts of the world. This industry is actually growing. Now, what happens in this industry? Before I explain, many bigger businesses, large companies like British Petroleum, DuPont, Exxon, Mobil, General Electrics, favored this carbon trading approach if certain rules and conditions are met and if applied fairly and equally for different parties of and to different countries. Now, first, there's a governing body. It could be a government, private organization, intergovernmental organization that sets up a cap, a maximum limit of emitting carbon for a particular company, right? Now, what are the ways you release carbon? Well, it could be fossil fuel burning, it could be deforestation, which actually is the destruction of a carbon sink, right? Which actually increases the emission. So there's a governing body that will set the capacity for a particular company to emit certain levels of greenhouse gases to the atmosphere by different actions. And now certain members, or particularly certain countries, may not reach the capacity, and certain countries may actually invest in not producing carbon, but uh, in processes like reforestation or forest restoration, which actually generates carbon sink, which decreases atmospheric carbon, right? So in that way, certain countries or certain companies that is in the business of forestry will generate carbon reserves. So members of this agreement, nation or companies that are likely to or that want to exceed their capacity, a maximum capacity to emit carbon, can purchase those carbon credits in form of carbon reserves from countries or companies that actually did not meet the capacity or did not meet the maximum or actually created carbon sinks, right? So, and the members that either create those carbon sinks or that have not met the maximum allowable emissions can sell their reserves, carbon reserves, to the other companies for a particular price, right? And now that has been favored over carbon taxing. Now, carbon taxing is actually any company that emits um, more than allowable paying a tax like a penalty to the government. Okay, so many private organizations, even certain countries that are known to emit a lot of carbon, favored this trading approach because trading approach actually helps um, countries that are more environmentally friendly, the governments that are more environmentally friendly, companies that initiate businesses on the green industry, on I meant green energy industry. Um, so this carbon trading is actually working at global scale. There are agreements between Canada and South America, Australia and South America, certain Southeast Asian countries, and developed countries, uh, where this carbon trading permitting system works successfully. Okay, now what are the other options we can take to minimize the impact of climate change? Well, seeking alternative and renewable energy. We talked about this through one of our discussion papers. Well, what are the options? Wind power, solar, geothermal energy, tidal energy, use of biofuel, um, hydroelectricity, right? Those are actually some of the options you can take. The biofuel could come from agricultural waste, farming waste, um, and also protection, conservation, and management of carbon sinks like forests, wetlands, oceans. All of those are carbon sinks. And developing appliances that are energy efficient, developing automobiles that are energy efficient, and has gained great momentum in this in the past decade or so. Um, Certain countries like Costa Rica, have actually vowed to become the first nation that is carbon neutral, and their target is to reach that level by 2030. Now, what is carbon neutral? Well, it doesn't mean that you are releasing zero carbon. No, it's not that. It meaning um, the amount of carbon or amount of greenhouse gas you release is also absorbed by carbon sinks. That's what it means. So that involves, of course, cutting down certain emissions and also increasing mechanisms that absorbs carbon from the atmosphere. Um, by 2010, I couldn't figure out. I could not find a more recent update, but I know definitely by 2010 there are at least 30 U.S. states that has set goals at state level to reduce the greenhouse gas emissions, and this number will actually grow with the climate coalition that the U.S. Local governments are setting up now. And most of these states, as you may have already guessed, are actually the western states: Oregon, California, Washington, and many New England states, many new northeastern states, including Massachusetts, New York, New Jersey, have set up goals to reduce carbon emissions. And agriculture, animal husbandry are sources of carbon, or ways carbon sinks are destroyed. So making those industries more sustainable also reduces the carbon footprint from those industries. And since 1990s, it was the during the 1990s, there was a huge global movement or kind of an understanding that climate change is going to be a problem. Back in the days, they actually didn't use even the term climate change; they used the term global warming. So by that time, there are about 650 cities around the world, right? And most of them are within the US, have established different programs to reduce greenhouse gas emissions, also within city level programs to increase carbon storage in biomass. So there are lots of efforts that actually started decades back and still going on. El Nino is a term that you are very familiar with right now. Now, first of all, okay, what is El Nino? That's the first thing that we should address. Well, in El Nino, we don't exactly know what drives this process. This is quite historical, right? It happens over decades at global scale. So what happens in El Nino situation is that um, there's a pressure difference, growing, between the two ends of the Pacific Ocean, and as a result of these pressure differences, the wind patterns change. So consequently, what happens is ultimately a warmer weather develops in South American, Central American component, and a kind of a cooler weather develops uh, at the other end of the Pacific Ocean, right? And the reversal of this is actually called La Nina, the kind of the opposite of this. Now, this actually creates very dramatic climatic conditions, climate extremities, which ranges from extreme prolonged droughts at one end to floods and storms and hurricanes at the other end. Now, is El Nino driven by climate change? Answer is no. El Nino is not driven by climate change because we have evidence that the El Nino southern oscillation have happened historically way before we noticed the trends in climate change. Okay, so no, the answer is no. But you look at that diagram, what I'm trying to tell you now is the severity of El Nino is increasing, right, with climate change. Now that we know for sure. That's what I'm trying to show you over here. And for the last one, again, I ask you to check out this interactive map of National Geography that actually identifies different outcomes of global climate change in different parts of the world. Well, with that, we end my lecture on climate change.